amongst the most profound science that we need now to understand challenges that we face. And in terms of my background, I went to university thinking I wanted to be an astronomer. I studied, which I enjoyed. I still enjoy astronomy a lot. I studied astronomy and I realized two things. One was, this was the late 1980s, and astronomy involved a lot of sitting behind a computer. and I loved being outside. I loved being surrounded by the things I was studying, and field work, and it was very natural. I loved that humility of being surrounded by the things you're studying. And also, as a student, it was when climate change was emerging as a subject area, and I also was very influenced by the books of James Lovelock, the Gaia theory, and whatever the details of that theory, which is controversial. I think that way of seeing the world as this connected entity was really inspiring. I thought, I want to use my physics skills, but apply them to these important global challenges like climate change, but also to understanding the world and how it works.
Well, physics is like the tool you need to understand how the world works.
Yeah, I think so. I think there's lots of biology contributes as well. Other things I don't always want to say physics is the superior science. But I think what physics does train you is to simplify complexity. So you see something complex and you look for the underlying patterns. And you make approximations and you say, well, what if I assume that it's this simple? How far can I go? There's a famous textbook in physics called Consider a Spherical Cow, Consider a Round Cow. And it's about, if you assume, trying to work out the energy of a cow, the easiest thing you do is assume it's a sphere. And then you can, mathematics are very easy. And of course a cow is not a sphere. How far can you go with the simplification before you have to do that legs, you have to have a head or whatever. And I think that physics way of thinking of something as complicated as a tropical rainforest and saying, well, let's start with first principles and understand it, and then add complexity to it. It can be a very helpful way of understanding complex systems. And I think Martínez, although he didn't formally train as a physicist, his thinking was very much physical sciences and looking for these underlying patterns of information and energy and how ecosystems respond, which I think for his time was very, very rare. We really need to have that big insight.
But to jump into ecology first, you would jump into meteorology?
Yes.
And then in Brazil?
Yeah, yes, that's what we say. Yes, so my PhD was in meteorology and climate. A significant thing there was I worked a lot in West Africa, in Niger, the Sahel, looking at water and drought and to understand to what extent was the degradation, overgrazing, causing the plants to not transport water to the atmosphere, causing drought. So, but ultimately it turned out it wasn't important, it was the ocean. But I realized I really enjoyed doing science in difficult places. So I loved going to the Sahel, camping out in the Sahel with Fulani nomads under the stars and doing my research. So I think I realized how much I liked. And I had skills as well. I could do complicated technical things in a difficult location and enjoy it. And enjoy the culture and the food and different things. And so I was hired as a postdoc to go to Brazil and this was the time a new technology called Ecological was emerging to measure fluxes of carbon. And the question we had is, was the Amazon absorbing carbon dioxide? And how much was it absorbing? And was this contributing to the slowing down climate change a little bit? And people suspected, we had no data. And so we built this tower in the Amazon and we measured this flow of carbon and breadth of the forest for a year. And then ultimately, that's another work led to the conclusion, yes, it is. And the rate of climate change would be around 20% faster if the tropical forest weren't absorbing carbon. So they provided this service. But at the same time, I was in Brazil. I was learning Portuguese in the bars on the Nas. But I also got absolutely fascinated by the rainforest. And I'm looking at a map humanity was so small, and it's something here. Nature is protected and precious and protected, and suddenly be a place where it was huge, and you were small, was very humbling, very, very influential. And so I.
But working there was really speaking alive. Like I think there are like thousands of things that can kill in the middle of the tropical.
Yeah, I think it's exaggerated. That's my impression. I just found it fascinating. So I really taught myself ecology in Brazil, partially because I was waiting for months for my equipment to clear customs. So I was in the library and reading about tropical ecology, and also started in the most complex of systems, the tropical rainforest, and trying to understand these patterns. So it extended from there. And ultimately, I like to think that the work we did there helped protect the Amazon, because this recognition of the Amazon as this carbon sink certainly influenced the Brazilian government to declare that it wants to slow down deforestation. Before then, the story was, well, we need to clear the Amazon for development, for progress. And then actually that changed the story with the Brazil, our science, but also the fact that we were working with training Brazilian scientists, then went to the government, to the ministry, to NGOs. There were strong Brazilian voices who understood the science and why the Amazon was important. And I think that's helped change the future of the Amazon.
When we talk about climate change and all these things that evolve with the planet, we always focus, or we are mostly focused on the north and so forth. But you claim that the rainforest is, I don't know if much more important, but we really need to focus also on the rainforest.
Oh yes, absolutely. Yes, the absolute change in climate is strongest in the poles, but the tropics are the most climatically the most stable part of the tropics of the world. So a small change in climate in the tropics in temperature is takes species to something they haven't experienced for millions of years. And so you have to understand how much does it matter, how much can the forests adapt to these changes, how much will it struggle with these changes. That not only matters for the forest, but because of these things like carbon sink, cycling of water, it feeds back to the whole planet. If the Amazon suddenly becomes a carbon source, then we have less space to stabilize our climate. It becomes harder to meet our climate goals, because suddenly this forest that was our friend in slowing down starts becoming an accelerator of climate change. So understanding those thresholds and how we can protect and maintain the Amazon is important for all our futures.
Which are the main threats to climate change, or?
I'd say the humans. I think historically it's been deforestation. Clearing for Capdevila in particular has been 80% of deforestation in the Amazon. That's slowing down now, thanks to the policies of the Brazilian government and others. Fire is now emerging as a threat. Links as climate change mixed with the deforestation, because the climate's drying the forest, and then the deforestation provides fires, people ignition points that spread into the forest. So there's signs of progress. There's also signs of alarm as well there.
Do we still have time to restore those articles that we are using? Just about deforestation, now it's slowing down thanks to the politics. But can we restore, or what is lost forever?
I think we were discussing this a lot. I think restoring to what it was in the past is very difficult. I think climate change, in particular, makes that climate is different from the climate of the past. But restoring things that are semi-natural, that are full of ecological processes, and make them adaptable to climate change, providing shelter for climate change, those things are possible. So it's restoring processes rather than necessarily restoring exactly a forest that existed. And partially because also the forest, a mature Amazon forest, takes hundreds of years to get its complexity. So what we restore is something that has some of that complexity, some of those functions. But I think part of the message that I had in my work is that that's okay. That actually what in efficiency of agriculture means that globally we're reaching a flat speed. Certainly in the tropics it's still expanding. But I think there are two things. Firstly, within agriculture we can have more nature-friendly agriculture or less nature-friendly agriculture. So getting corridors of natural systems between the fields so that species can migrate. You could design agriculture with nature in mind, climate change in mind, so we can still feed and have nature. But then also I think we have to be ready for the fact that I think some of these larger pressures are beginning to turn. Land is stabilizing, agriculture. Human population will stabilize probably in the next 20, 30 years. Already in many parts of the world outside Africa it's already starting to reverse. And even the consumption footprint is beginning to change. There's lots we have to do there to improve that. So one of the things that I'm very interested in is are we ready for this opportunity to restore nature when the opportunity, when the macroeconomic pressures change. We could either just let things be and have something that's quite poor, or we can actively think about how can we design our rural landscapes to be better for nature and bring back resilience.
This is a debate you're having in Africa as well, because it's a lot of agricultural landscape is an island right now, and there are a lot of woods, where we have and everything. And yeah, also like here for the fire here at high availability of energy. And now there's this debate going on whether we have to design the nature we need to have to be more resilient to climate change, or let's like let nature expand. So when you talk about restoring nature, what do you mean? Do you mean designing nature for our needs right now to be more resilient to climate change, or try to like mimic what it was once upon a time? Or
That's an interesting question. And firstly, I'll say I'm not an expert on fire management in Catalonia, so it's an outsider's view. But I think there is a tension there that certainly an element of design is needed. And we've given this opportunity and the threat of fire to how do we create fire breaks and landscapes that don't threaten towns and livelihoods. There has to be an element of design. But there's a danger of over-design. If you try and control the landscape too much, it backfires, and you can have bigger problems. The classic one is fire suppression in the Mediterranean or in North America, where for a long time, because of houses, fire was suppressed and the fuel builds up, and then when the fire comes, it's far worse because all that fuel is there. And that's going to be the case more so with climate change. So I think it's a mixture of a judgment between some elements of design to steer where you can, but also letting the natural processes work. If you suppress the natural processes, you can often cause more damage in the longer term, like the feedbacks and fire. But I think the detailed orders require understanding that system. But I think those principles are not over-designing. The problem with nature is it's quite unpredictable. And if you try and over-design, it just explodes in your face. So you have to steer wherever you can without setting an end goal. This is what we want.
what is an example of a successful restoration project? I mean, for example, I wrote a book with this photographer in Brazil, and he also had
Oh yes,
this successful that he restored the whole area.
yes.
I know that you have more experience.
Yeah. There are many examples. One that's very famous in the UK, you might have heard about, is NEP, the rewilding project,
Yeah.
where 20 years ago these farmers, they were trying to farm more and more intensively, more in the land, and it was just costing more and more, and they were losing more and more money, and they just stepped back and they said, "We can't do this anymore. Let's just rewild and you can't bring back the lost wild animals, but let's have the horses roaming and the cows semi-wild." And suddenly all of this nature came back, and they also came up with an economic model that was actually more profitable than their farm. And since that's been hugely influential in the UK. So now every week I have farmers calling me, emailing which is good in some ways. I think I think what you also have to have then is connection between these projects, so that the animals can move between them. But that has been hugely influential, partially, but also when they wrote a book about it after 10 years, already they could show the results. There was a lot of people that were talking about rewilding at a very abstract, conceptual level. And suddenly here was a farm saying, well, if you actually just step back from nature, amazing things happen. And we could show what was happening there, and species that no one expected to come back. And I think that's inspiration for a lot of what could happen. So certainly we have to think about all the other factors. Another thing that got me very interested in restoration in Europe was that for many years I was working in Brazil on trying to, on the science, but also trying to influence how to slow down deforestation, protect the rainforest. And all of those things I still very much believe in. But many times, even my friends, the ecologists, that are the opponents, the cattle ranchers, would say, "You're doing this, but you're living in the most deforested countries on earth, and your country's got rich, partially by clearing their forests. And who are you to tell us in Brazil how we should manage our land?" Many Brazilians disagree with that argument, and others, but I think and you can argue for very different reasons why it's wrong, but actually it did make me think, actually, Brazil has so much more that we can do in Europe, in the UK, in improving the ecology and the health of our landscapes as well. In my case, also links the time was linked to COVID and having a year when I couldn't go to the tropics, and when I was walking, where there was a time when you were only allowed to go outside of the town if you were doing work. So I called these farmers and said, "Can I come and see your farm?" And so I spent a lot of time talking to farmers and understanding the challenges of biodiversity in the local landscapes and thinking through these problems in local.
Well, you were talking about farmers. Well, you said that the agriculture is like going down because I was going to ask about our food grains, because the way we eat right now is of course eating plants.
Yes, sir.
And I think it was last week or the other that we, I remember I was writing that we have just passed another planetary tipping point. So sometimes it's very difficult to be optimistic about what to write or what to say, because I want to be all the time like this
Yes,
very strong all the time.
yes.
But I look at it and I see you very optimistic. So I'll move my hand.
Well, I think I'm always asked, as we discussed this morning, also in lectures, are you an optimist or a pessimist? And part of it is psychologically I'm an optimist. I think that's just the way I am. But more than well, seriously, my definition of optimism is clear-eyed pragmatism. So it's clear-eyed in the sense that we understand the problem. It's not sort of, "Oh, it's going to be okay, you don't have to worry about it." It's still not understanding it. But then it says, given the problem, what can we do? All we can do is act. And let's find out the best way to act. And I think there are actually, when you do that, you start seeing many stories of hope. Like these rewilding projects. We were also talking this morning about the wildlife comeback in Europe, how the wolf and the bear and these creatures are near extinction. And then I know there's always complications and problems, but it's actually, sometimes I don't think we tell enough of the stories of what's happening that's a sign of hope. also direct our Centre for Nature Recovery, and the first year we thought about how to define nature recovery, which is a very technical definition in the UK, and we came up with helping life on Earth to thrive by restoring human relationships with the rest of the natural world. And there are three parts. Helping life to thrive, so it was about direction. It wasn't saying going back to the past. So it means more nature in cities, more nature in farms, as in wetlands. And it was about relationships, so restoring relationships. So that works at the personal level, or the city, or the local, but also the political level. How does nature sit in our economic system and financial system? So changing, looking, exploring of those relationships and thinking more. And then with the rest of the natural, the rest is important. That we really want to emphasize that humanity is part of the natural world and not something separate. Nature's there, and the idea that we've come from the natural world, species evolved on this planet, and everything we're doing is intended for the world. So try to read. So they're the principles that we try and work on. But also, at the same, as I said, as well as the ecological impacts of that, I think if we change our master's class, we've now got a master's in biodiversity and nature recovery, and the students that come through are so motivated, so wanting to make a difference to the world, improve the world. It's really energizing to see that. No, I think there are big issues, and I certainly don't want this message of open engagement to say that we mustn't fight the really bad problems that big oil companies and big companies are doing. So I think that we still need to fight. It's not that. And recognise those problems, challenge them, as people are continuing to do. But I think you need to do them also with a sign of hope beyond as well, so that you can win these and you can change things in the future. So yeah, I think at the moment we are, as you know, geopolitically not a great place. There's a reversal of the progress that we had. But I see part of I think what we're doing is planting, when the pendulum swings again, planting the seeds for what could be the next stages of what this is part of. Trying to push the pendulum back for sure, and fighting that time, and also pushing for that. And I think perhaps many factors, but perhaps part of the problem was that our environmental stories were always about the disaster to come, and how we must avoid disaster. And I think many people in the US and other places perhaps just got tired of that story, and they're looking for a simpler story, and Trump and others can say, oh, it's fake news, and that provides them with a simple story that they can attach to. But maybe we can create stories that are stories of hope, about a world where people and nature can be better understand. And maybe it's always complicated, but it's a heavy part of that solution. I think that we need to try and work for. So one other project that we're involved in recently, we're working with the UN Human Development Report that produces the Human Development Index. And so we had a paper a few months ago in Nature we started doing this in 1990, there's always about climate change in the future. And now it's always the climate change now. So the studies we are producing are how have the forests changed in the last 2 decades because of climate change. So it's very much tense in which we speak has changed. I think the mood has changed from being an abstract sort of scientific concept of alarm to being a lot with high alarm and despair. And as I said, I think that despair story is running dry, and
funciona. El Santi ens introduirà. Llavors, jo sí que de fet... No sé si estàs molt cansat, Santi.
Com vulgueu, si no cal que et presenti.
No, però vull dir, quan facin preguntes ja passo jo amb el micro.
Què feu? Aquí n'hi ha un altre. Però jo crec que com que estan força a prop, excepte els dels darrere, ha anat un moment al cervell, perquè és que avui és com un dia un pèl intens, un pèl bastant intens. Moltes gràcies per venir. Ara la idea és que, no sé, segur que, no sé si tots heu estat aquest matí, si heu estat fantàstic, i si no heu estat us heu perdut una xerrada molt, molt interessant. Però ara la idea és que estigueu molt relaxats, és que tot el que penseu que us pugui interessar del que us pugui explicar, li pregunteu, fem un diàleg i llavors ara us deixo amb el Pol i l'Eli que portaran aquesta part de l'activitat. Jo ja ho deixo aquí, que avui ja en tinc prou.
Sí? Molt bé. Sí, home, sí. A lo Madonna.
A veure si em dones bé.
Si vols ja passo jo amb el micro.
Anem tornant.
Sí.
Aviam, això.
Hola, què tal?
Aviam. Ui, sí. Sí que és Madonna. Això t'ho penges?
Què es fa?
Ho tenia com una antena.
Esto no es serio.
Així millor? Sí, us agrada més? Assessores? Explica'm una mica la idea que havíem pensat o ens esperem que vingui ell? Ai. Ens esperem que vingui ell.
Comencem, sí, si vols. Vinga.
Vale. Bueno, pues benvinguts i benvingudes, no? A aquesta segona part del Premi Margalef. La idea que quan vingui ell explicarem és que sigui una tarda de discussió i que puguem anar més enllà del que és la ciència i potser tenim l'oportunitat de tenir una persona com ell aquí i és el moment que podem preguntar coses que també ens siguin útils al dia a dia o per la vostra recerca o per a la nostra... Ai, sorry. Eli, nice to meet you.
Pol.
So I guess we are very tired.
That's okay.
So the idea for this afternoon is to have a relaxed discussion, and we have now the more young researchers here. So what we want to do is to go beyond science. Of course, we also talk about science, but it's a unique opportunity for them and for us to have this time to talk to you. And maybe we can also discuss about other topics like, I don't know, academia, or how is your trajectory, or all these challenges that I'm sure you face at some point.
Yes.
And as a young researchers that they just starting their career, I guess they can get some tips or some insights and understand better how the system works, that sometimes is not wonderful.
Yes.
But that's the idea. So we have, Paul and I have some questions for different topics, but the idea is that it's something dynamic, and it's very relaxed, and there is no wrong or bad questions. That's very important, that we can discuss everything. And yeah, so we wanted to focus in different topics. First, science, of course. As Santi said before, I don't know if you were here this morning, but he gave a wonderful and fantastic presentation. Thanks a lot. It was very inspiring. And so we can also discuss a bit about his science or his research. And afterwards, we can move to different topics, for instance, like mentoring or life-work balance or career perspective and other things that, as I mentioned, are relevant and maybe as a young researcher, it's something that you want to know more from someone like him. So if you...
Something maybe might be worth mentioning. I don't know, Yadvinder, how good is your Catalan, but if someone is not confident in asking the question in English, we can translate. There's
Puedo
no
hablar
problem.
castellano más o menos.
Wow, okay.
Wow.
Catalán no tanto.
So he's flexing here.
That's a new skill
Nice.
that we didn't know.
Nice. Okay. So maybe they can ask in Catalan, and if you don't understand, we can translate,
Yes,
if that's okay.
Or in castellano, maybe easier.
Okay.
So we can start with maybe some scientific questions. So if you still have some questions or ideas or comments that you would like to ask to Yadvinder now. Otherwise, we can break the ice, and maybe you get a bit more inspired or you have more ideas. Should I start, or do you have some questions regarding scientific perspective? Here we have one. Maybe you can introduce yourself or say your name.
Okay. I'm Feng. I come from China, and now I'm studying UAB. So today I come here to study from professor. His presentation is very good. I read a lot of papers of the researcher. And now I have two questions. Today you have a presentation the energy as a way of ecology recovery. So I want to know, is there any method I can connect above ground and below ground the energy? So how can I connect the above ground and below ground the energy?
Energy, okay, right, yes. So it depends. Obviously, with plants have above and below ground productivity,
yes,
you can talk about energy. But when you think about the whole ecosystem, you also then need to think about the food webs.
Yeah.
And one of the major insights, I think, from the last 10, 15 years is that the below ground and the above ground food webs are not disconnected. That previously, when we tried to estimate a trophic efficiency, the flow of energy from animals to herbivores, the model was you measure productivity, you measure herbivores above ground, and you work out the energy flow. In most cases, that doesn't work because a lot of the energy flow is through detritivores, to the invertebrates in the soil, that then are eaten by the invertebrate-eating animals and mammals. So you have this below-ground food web that then ends up feeding the above-ground food web. So I think this connection, the web way thinking, the energy way thinking, shows that there isn't a separate, distinct above and below-ground ecosystems. The two are actually exchanging energy in quite substantial ways.
Yes, thank you. I have another question. I mainly study the soil nematode. Under the climate change, the energy will be redistribution between soil food webs. Maybe more energy to soil microbes, or maybe more energy to soil nematode. So after the soil food web changes, how the energy affect the soil function?
Yeah, that's a good question. The details of it, I think we don't know the answer to, but I think some of the work that some of my students are trying to do is come up with detailed descriptions of energy flows in soil webs.
Yes.
And then to see how it maps onto other different soil functions like nutrient cycling and soil bioturbation. And I think the hypothesis is that we can do a little bit like what I showed in Africa above ground, that we can show that the amount of energy flow into different animal groups below ground is maps onto the functions.
Yeah.
But we need to test this to prove this. And then that you could use energy flow as a measure of the health of a soil. And that all becomes intrinsically quite interesting to when you're talking to farmers or others about healthier farming methods. You can talk about the sounds or the energy flow in the soil.
Yes. Thank you. I still have another question. Now, I live in Guangzhou, China. It is also a tropical forest. The field is very field. So now we also want to protect the tropical forests in China. So can you give me some suggestions to protect the tropical forests in southern China?
Okay, yeah, that's a very specific. I can't, but I think certainly, I think there's in China also there's increasing recognition of the value of the existing forests,
yes,
and restoring forests as well. I know China's been very ambitious in
yes,
declaring strong targets for restoring. So I think the specifics, I can't really go into it now because I don't know them, but I think more generally, I think clearly making sure the message of how valuable these forests are, both for their own biodiversity, but also in the resilience and functioning of the whole landscape, is something that's an important thing to get through to policymakers and then to influence those policies. And China's aspiration,
yeah,
China talks about an ecological civilization and that lives in harmony with nature. So these protecting and restoring nature very much fits into that part of policy.
yes. Okay, thank you.
Hi, I'm Paula, PhD student here at the University of Barcelona. I really enjoyed your talk this morning, so thank you very much. I have much rather curiosity. I read your website yesterday to prepare a bit for this relaxed small talk. And I read you're doing something in the Arctic and the Antarctic. I'm just curious, what are you doing there?
What am I doing there? Yes.
Yeah.
So that was originally driven by, so one of my interests, as I mentioned in the talk this morning, was around animals and how they shape ecological functions. And we started looking at rewilding, and we looked at savannas in Africa. And then I have a colleague, Marc Macias Fauria, who's a Catalan, who's a Arctic ecologist. He was in Oxford, he's now in Cambridge. And then we started, in pubs, as we often do in Oxford, have these ideas. We started thinking about doing similar work on animals in the Arctic. And then we heard about this project called Pleistocene Park in Siberia, and where a couple of very crazy Russians were reintroducing bison and camels and horses into the high Arctic. And the hypothesis behind that was that where we have tundra now, we know when we look at the paleo data from 15,000 years ago that there were mammoths, there were bison, there were lions, there were rhinoceroses in the high Arctic, in the ice ages when it was colder than now. And how could such an unproductive ecosystem support so much animal life? And the hypothesis was that the animals, through the accelerated nutrient cycling, were creating a grassland which is called the Mammoth Steppe, and it extended from the UK to Alaska. It was the largest biome on Earth. And it was, why it was maintained in this cold climate was because the animals were accelerating the nutrient cycle. So now, when a plant dies in the Arctic, it takes 5 years, 10 years for it to decompose because it's so cold. And yet, when you have a mammoth, it goes inside the stomach of a mammoth. It's a 40-degree acid vat. And within one day, it's turned into nutrients and defecated to the mammoth. So that was the original motivation, firstly to see what was going on in Russia, and then try and test the science that they were claiming around these ideas. And this was in 2019. And then we got a grant to work. And then the grant started a month before Russia invaded Ukraine. And so clearly we weren't going to work in Russia after that. And so, but then after a pause, we then moved the work to Greenland. And we're looking at the musk oxen and reindeer and the tundra ecosystems of Greenland to look at the degree to which, so the musk oxen is interesting. This large animal, it wasn't present in Greenland until 1960. It was reintroduced from Canada, 14 individuals, and now there are 15,000 in this area. So we were trying to understand how they were shifting the ecology of Greenland, of the tundra, and also whether this was good for climate change resilience or damaging climate change resilience of the tundra. And we don't have a full answer. I think it's good overall for the resilience. So we started doing the same things that we were talking about, the energy flow, nutrient cycling, in the high Arctic. And the nice thing about it is that the basic principles are the same. So the ideas that we developed for the tropical rainforest, you can apply to the Greenland tundra. And actually, you can learn more about both by starting to compare the patterns in Greenland and why are they similar or different to the patterns in Malaysia. And that's a nice thing about this global ecology, that you can start seeing some of the underlying patterns, the rules of life that are emerging. So, and I love, even though my career has been a tropical ecologist, every time I go to the Arctic, I love it. It's a magical place to work. The skies, the landscapes there as well.
Questions? Maybe I can ask one directly. Today, when you were showing these global maps, I kept thinking about uncertainties, because at the end you're upscaling from energy to food web to the ecosystem functioning. So all this, when you start upscaling from the productivity to the animals, population density, how do you deal with uncertainties? I guess that they're huge at the end. You do have a direction of your models or the results, but how do you deal with such amount of uncertainties, I guess, you have?
You sound exactly like one of our reviewers. It's a very important question. That every measurement carries uncertainty, and you have to recognize that. And so what we try and do is formally propagate the uncertainty. So you have an uncertainty in your measurement, you have your uncertainty in your assumptions and systematic, but each of those can be mathematically described, and then you can push them through your calculations to say this is your overall uncertainty. And what we find when we do that is, for any one species, there's quite a lot of uncertainty, because all the assumptions are there. But once you add across lots of species, the individual uncertainties, many of them cancel out, because one species may be biased this way, another species is biased this way. So it's a little bit like any random process, that you can end up having smaller uncertainties on the whole ecosystem than the uncertainties you have in any one part of that ecosystem, because of the way the errors sum up. But it's really important to always be clear and quite formal about those uncertainties. And either mathematically or in computer modeling, you could do Monte Carlo simulations and sort of describe the different scenarios and assumptions you're making to calculate through those uncertainties.
It's very impressive. Still to see these big maps for me is like very nice. Questions? Should we keep in science, or do you want to change topic?
Let's wait 5 minutes for a silence, uncomfortable silence, and see if someone dares to ask.
I can.
It always works.
Hi, I'm Yanis. I'm a PhD student here from I do marine ecology, so I thought it was a very interesting talk. But I don't know a lot about tropical forests. But I was thinking, I really like this energy approach from an ecosystem functioning approach. Like, I can understand how we can easily see the function of a system, right? But I was also thinking, and also a little bit in the direction of what you were saying about baselines, that like some of the losses that we might be having, taxonomically speaking, that are being like hidden under this like more functional perspective, I feel like still having a baseline is needed to know that they have occurred. I don't know, like I understand that trying to get back is not possible with current situation, but yeah, I wanted to hear your own opinion on this topic, basically.
Yeah, I think it's a little bit like what I said in the debate this morning. I think baselines, well, past information, I'm not sure what a baseline means, but a past information on the state of an ecosystem is an important bit of information that we need to have, and that includes the rare species, what's unique to that area, and that can help inform our decision. So I think where I pushed back against baselines is the idea that we can somehow go back to a baseline, and the baseline is our destination, our target, because I don't think we can in most cases. But we can be informed that these species were there, these things, and maybe they can still be there under the current climate and future climates. this functionality approach, I think it's only, I would never argue that functionality is the only argument that we should have, the only way of looking at things. There are sometimes we want to just value something because it's a rare, unique product of evolution, some rare species that phylogenetically distinct from everything, and it's a precious product of evolution. That, it doesn't have to be functional. It's just important because it is. Sometimes I think perhaps in biodiversity science we try and emphasize the functionality of everything too much. So we have to say, oh, this rare plant matters because the functional diversity of this ecosystem, it enhances that, and therefore this ecosystem is more resilient. I think the actual evidence that that rare plant actually makes a difference to the ecosystem is probably tiny. It's interesting just because it's interesting and it's unique, not because it's changing the ecosystem. And so sometimes we shouldn't use functional arguments too much when we just mean rarity and uniqueness as values in themselves. But at the same time, I think then functional arguments provide a slightly more fluid definition of ecology that's helpful as well. So we're not too obsessed on the role of non-native species and other components, particularly in the context of climate change, where species are migrating from warmer climates northwards. If we obsess too much about does it belong here, does it not belong here, we'll just get distracted and confused. I think we have to accept that there's going to be new mixes of species, and can we maintain many of the ecological functions, while also protecting what's unique and special where we can. Sometimes it's simply we won't be able to because the microclimates, the microhabitats are no longer there. So it's a pragmatism to it as well, I think, there as well. I think part of it is perhaps pushing the, what we could call the biodiversity values, the rarity values, and making sure we understand them as distinct from the functional values, rather than confusing the two, which I think it's overclaimed sometimes that rare species matter for the functioning of ecology. They don't. They matter because they're rare, and and they're unique, and that's fine as well.
You show us today that, you show that your research is very interdisciplinary, right? You show from remote sensing to modeling, site plots. How do you see, or where do you see the gaps in research? Or let me phrase it in a more positive way, like what are the new tools or the new avenues that you think that will be the next generation that will improve our way to see ecology?
Right, yeah, okay. What are the real opportunities? I think simply, partially, it's one that isn't that much technology focused, but just expanding the spread of ecology around the world. One of our big pushes has been in these tropical networks to support capacity in South America and Africa, and so that there are stronger ecological research foundations there that hopefully can lead to ecologists from those countries being influential. And so shifting away, if you go back all the way to the 1960s, ecology was a North American and European science. And I think a lot of our early ecological thinking is biased by the way the North American and European ecosystems work. And I think what has happened over the last few decades is we started getting a truly global ecology where insights from tropical rainforests, savannas, mangroves, marine systems is feeding into this collective ecology. But there's more to be done. And if you look at the coverage of good ecological research sites in Africa, for example, it's tiny. So this is not amazing new technology, but just spreading so that the geographical biases of ecology towards Europe and North America and Japan are changing too. So that's. Then I think I'm sure the technologies bring new tools. I think remote sensing already is beginning to yield really new insights into spatial patterns and functioning of ecosystems. And we've done some work recently coupling our plots to remote sensing to show how functional traits vary across tropical rainforests. So for now, we're not, before we modeled and others just treated them as a single homogeneous, the tropical rainforest. And now we can see how biogeography and geology and land use have shaped all of these functional properties and where they come from. So remote sensing is one. I'm sure new tools will emerge as well. AI, it's with lots of challenges around AI as well, but I think the opportunity to be able to mine complex information, big data, to get new insights, certainly there's huge opportunities there that we're just beginning to understand the potential there. So.
And the danger as well sometimes.
And danger as well, yes, yeah. But just one point I would say is, even with all these new technologies, one thing I strongly believe it is the importance of fieldwork, of actually collecting primary data. I don't want to see a world where we think the satellites and the computers can tell us how the world works without the experience of real measurements.
I totally agree, and I really like this morning that you really stress this point, because most of us, I guess, we're doing a lot of field work, so it's the value of this kind of data. It's valuable.
So a very young researcher has a question.
Sorry, but it's a question for the young research itself, because there are many PhD students here, and if they were willing to visit your lab or some of your experiments, what do you think, or you would recommend there are, room for them to do some work with, giving them so many interesting things you are developing everywhere, but some of the grants, they have some funding for stay away for 3 months, or depending on the grants and so on, or sometimes are linked to projects. What do you think would be a nice place to work with you if any of them have the idea to visit you?
Yeah. Well, there's a whole range of possibilities. I think it would always be involving working on what works for that PhD, what works as a practical project if it's like 3 months in the field. And I think a lot of my recent work has been this multi-trophic energy type things, but we have projects in the Arctic, in Europe, in Africa, around that. Another approach is also if students are working somewhere and they want to take some of these ideas and apply them to field sites where they may already be working on others. That's another way of trying to link up as well. So, and then I have to say also, like talking to my wider team, my lab is about 25 people, because sometimes I'm a little bit drowning in all the things that we're doing with people and students as well.
Sometimes they are shy to ask for.
Yeah, I'd always say never be shy. And also, if you don't get a reply to an email from a professor, just email again, because often it isn't arrogance or anything. It's just the professors' emails are so crazy that they never keep up. Like, I'm here today, and I know when the next time I look at my email, there'll be 150 emails as well. So sometimes you just have to, as you're applying, and even when I was applying for my first postdocs in the 1990s, just being proactive, emailing out. If you have silence, just email again. Most people are not offended by you emailing again. They're just sometimes busy people just need to be approached a few times to make that connection.
Maybe we can link this to your career path. Maybe since it's very, very informal meeting, maybe you can make us a small summary of how was it? Because usually it's the interview who knows the career path, but in this case I read it this morning, but now I don't remember.
Okay, yes, yeah. Well, the first I'll give a quick summary of my path, but it was a little bit unusual. But the first lesson I always have from that is, don't be defined by your undergraduate subtopic. It's given you some skills, and then you can take them in many paths in life, whether in academia or outside of academia. So don't say, oh, I did an undergraduate in biology, therefore I'm a biologist, or a physics, or even a sub-discipline. You can say, oh, I'm a limnologist. No, you learn some skills in your discipline or in your PhD, and you can apply them elsewhere. So be very, go where your passion goes rather than being defined. So in my particular case, I started off actually as an undergraduate in physics, in natural sciences at Cambridge, but specializing in physics. Thinking I wanted to be an astronomer. And then I realized I really liked the natural world, I really liked field work. This was also the time when in the late 1980s, when climate change was emerging as an issue. So I want to apply it to these questions. And I also was hugely influenced by reading James Lovelock and Gaia. And the details of Gaia are controversial, and you don't have to agree with everything of the Gaia theory, but I think his way of seeing the Earth as this interconnected whole is sort of, very reminiscent of Margalef, but also very reminiscent of the sort of work I was showing this morning as well. And that was very much inspired by that reading. So the other lesson, I think, is read broadly. Read outside of your subject. Just read where your curiosity takes you, and then bring that into your work. And so after my PhD, I did a PhD in meteorology and climate science, working on vegetation in arid regions. Something that's hell. Actually, my first ever major fieldwork of my PhD was in Spain, in Tomelloso, in Castilla-La Mancha, in the middle of nowhere, measuring water use by pipelines as well. So, and in the summer, it was very hot. And then after that, I realized I enjoyed fieldwork. I enjoyed being in Africa and doing technical science in very interesting and complicated places was what I realized. And then so my postdoc was to go to Brazil and measure the flows of carbon in the Amazon rainforest, to look at this question of is the Amazon absorbing some of our carbon dioxide emissions? We know that there was a carbon sink. People thought it was the tropical forest, but there wasn't any direct measurement. So we built these micrometeorological towers to measure fluxes. But I was living in Brazil, in Manaus, and I just got absolutely bewitched by the tropical rainforest, and realized what was really interesting for me was not the technical climate measurements. It was actually the forest and the ecological processes that determined the behavior of the forest. So I really self-learned ecology as a postdoc.
Oh.
In my PhD, I didn't really do ecology as well. So and then that led on, and then I moved after 10 years to a geography department, and where I did the ecology, but also worked a lot with climate scientists, with social scientists, and realized that ecology, as I said this morning, is very good at describing the challenges of the systems, but the solutions always involve people. And so talking to the social scientists, the human geographers, was a really important part of that process of understanding social ecological systems. So it's been a sideways journey.
From Tomelloso to Manaus.
Tomelloso but I think the lesson for me in that is don't be defined by what you've done already. Define yourself by where you want to, what's interesting you now, and where you want to go with that. And don't think, oh, I'm limited because I only do this. You can learn new things if your passion is there. Follow your passion, sure. And to see where it takes you. I think the biggest, with giving career advice in academia, I always have to be conscious I have survivor's bias. Clearly, I've done well in academia, and things have worked for me. And for many reasons, people's careers don't always work in academia for personal reasons or structural reasons or anything. But I'd say that the biggest incentive is passion. If what you're doing, of course, everybody has non-passionate times. Like if you're struggling with your final phase of your PhD and hating your PhD, that's normal. But then, if in the longer term your passion for something is drying out, try and find something that motivates your passion. But also recognize there are many pathways beyond academia, in government, in NGOs, in civil society, that are as important. It isn't just the academic pathway that is the only pathway to aim to as well. So diversity of pathways, diversity of subject areas is, I guess, my lesson.
Do you have? Wait,
Hello, I'm Alba, PhD student. Thank you very much for the talk this morning. It was very inspiring. And so, in fact, this morning you was showing this Earth and So the energy that applying different systems, how much energy do we need, and if the China, not the Chinese energy, or even the United States, applying the United States system and this. So sometimes I feel that the scientists, we are showing all this data and how the politics impact in the earth, but what can we really do? So we are showing all this data, but we are a bit far from the real world or the society. So what can we do? And to feel more next to people and.
So if I understand, how can we get our science more connected to society? I think in many ways science is connected to society, and I think we need to just strengthen those channels. And I know you could argue that globally in the last year, we're in a particularly low patch in terms of people's engagement and trust of science. But I think this is a pendulum. I think it'll swing, and I think the messages of engagement with science are, and the use of evidence and objective knowledge is a really important value that I think we need to still be pushing and out there continuously in this time when there are these ideas that knowledge is subjective and you just make up your own facts about the world. So I think we still need to champion that. Overall, certainly there is a pushback against science, but I think we're also very dominated by what's happening in the US at the moment, and it dominates our narrative of how the world is going. But when I think you look globally, you don't necessarily see that. There's actually, when you look at the Asian countries and the rise of the challenges for sure, but also the rise of evidence-based ecological thinking about long-term sustainability. There's huge amounts of progress happening. When we look at South America and Brazil, Brazil has declared its ambition to stop deforestation by 2030. That decision, as I said, in the last 10, 20 years has been strongly influenced by the science that our colleagues and I was a small part of were doing in the 1990s, 2000s around the importance of the Amazon. Sometimes these things take longer. So, we can be distracted by the bad news of this year and feel there's no hope. But I think the important thing is there's a longer term, keeping going at that. So I think there's many challenges in the world, undoubtedly, but there are also many signs of hope as well. And I think we sometimes we have to look at the whole richness of what's there and be clear-eyed about the challenges, but also keep on pushing forward the message of what our beliefs are, what we think are important messages out there. And it has to be a two-way thing. I think one of the lessons in science communication that changed from my early career, where it was very much this idea that scientists produce the evidence and we give it to society, we give it to policy and say, oh, look, this is what biodiversity is going wrong. Now you, politicians, you solve this. It's your job to solve this. And actually that doesn't work. And actually what it has to be is this two-way conversation all the time. Because the politicians, they have many factors. It isn't just the science, it's economic, it's other social things that they have to consider. So they want, my experience of advising governments in the UK and some other places is that if they're willing to listen to science, they are willing to listen, but they want to balance that with all the other things in the voices in their ear as well. So having those relationships, those conversations, is a two-way conversation is important. And I think despite all the problems, I think still the world is still quite strongly informed by science and by the evidence of science, even if there are some regional setbacks at the moment.
So is there hope? You think that there will be changes in the future, that they listen again to science? Or
I would like to think so. I think still, as I said, there are many societies, even in the West, that there's a pushback against, but I think still European societies, I think, are still strongly, largely evidence-based and how they use science. I was recently in China, and I think the way that there's certainly challenges with elements of the Chinese system, but the degree to which they're doing long-term planning on environmental goals, but based on evidence, and of ecological restoration at large scale, the rapid transition to clean energy. You go into downtown Shanghai now, 60-70% of the cars are electric. The air is cleaner than it is in London. So and these are transitions that happen so quickly, and we're seeing the same in renewable energy, other components that will feed off into other. And each of those can be questioned, for sure, but I think sometimes perhaps our narrative is too focused on particularly the United States, and we sort of think, obviously is an important country, but we don't see all the other currents in the world and how they are also influencing the future as well.
Yeah.
I'm not person anyway, so I can talk like this. It's okay.
Yes.
No?
Yeah.
Yes, now. Yes. I'm a postdoc here. I just started like 1 month ago. And I'm going to ask like a complimentary question to her, actually, because recently I was thinking a lot more. Sometimes I'm feeling like we're doing science for other scientists. So I don't think my friends or like our families, especially when you're a postdoc, you keep changing every 1 year, 2 year the project and working sometimes totally different topic. And also when I'm working, finishing one postdoc, doing publications, but after that, what did I do and what the society learned from that and what the government implemented, what I suggested, whatever the topic, actually. And thanks to social media and all, like popular science is getting way faster, as you said, and yes, for governments can take some time to implement all these applications that scientists suggested and everything, but how often do you work with the governmental agencies or with the society or like with the society as a popular science scale it can be outreach activity or for you to be more understandable about your scientific research?
Yeah, I found myself doing a lot now in multiple ways. Everything from directly working with governments. I've been on panels with the UK government. I advise the Scottish government, some African governments on various things. So there are direct interactions, and then there's public communication of science. In fact, just 1 hour ago, I had a TED talk released, so it's just out. So you could find it on the TED website. It's about energy flow in nature, and so there are ways of communicating there. But obviously, I'm a professor, and maybe I have those connections and reach. But I think you can start many of those things quite early on. I think young researchers communicating their ideas, their science, is a really important part in the social media landscape, in the wider media landscape of sharing science and ideas. So I would strongly encourage my students and encourage you to engage with those things where you can. And they're not suitable for everyone. Some people to them, and not speaking in front of a camera is a nightmare and they don't want to do it. And that's fine. The different types of people with different skills, not everybody has to be a great communicator. But those of you who have an inclination to communicate and the personality to communicate, I strongly encourage that as part of what we need to do to make sure science and the rest of society are fully engaged and fully coupled. One other comment that you mentioned of the PhD and things is, I think part of the challenge of the academic path is when you start a PhD, quite often you go into a PhD thinking big questions. You've been influenced by Margalev in your lectures or whatever, and you have these big questions. And you start a PhD, and you're working on a very small problem. And it can feel quite frustrating. It's like, oh, I had these visions about saving the world, and here I am studying this plant-insect interaction here, or something. But that training is important. So what that PhD training does is give you rigor and depth in understanding a system in detail, objective scrutiny of your data collection and uncertainties and all these questions and structuring an argument. So it's an important skills training. And I remember certainly when I was doing my PhD, I felt this tiny wheel in a machine that was huge and not really having any influence. And that's a very common feeling. And so I think don't also be disillusioned when you're in a PhD and think, oh, my work doesn't mean anything to anyone. Often that body of work then feeds up, as it is, to a wider understanding of a system. But also it provides that training that then can be applied to as you develop an experience to bigger levels and bigger issues as well. So sometimes it is easy to feel insignificant when you're starting off a career and the questions and the urgency of the global questions are so big. Should I really be studying this when this is happening out here? But I think that those skills matter ultimately to answer those bigger questions.
Yes. So I have a question, maybe it's a bit of a hot topic, but I really value ethics in science, and I think for the longest time Europeans would go to like Southeast Asia, to Africa, to South America, and they would like do the experiments there and then claim all the knowledge and claim all the merit without including all the people that already lived there. And like there was for sure valuable people and like intelligent people out there, but maybe they didn't have the resources or whatever. So because you work in the tropics, I'm just curious, do you think you include, like you make sure you're including the people from there, like the indigenous communities or scientifics from their region? So,
yeah,
yes.
That's a very good question, a very timely topic. And so this is often described in science as parachute science or helicopter science, where well-funded students or researchers from the north go to the south and as you say, collect data, come back, maybe acknowledge their local partners, and that's it. That certainly has been a feature in all fields, but I think tropical ecology is at the forefront of this because the money, the research is in Europe, north of the money, but what we're studying are the tropical forests, the tropical savannas, where the biodiversity is. They've always been generally in poorer countries, so the inequality is very, very prominent there. In our work, I'd like to think, I'm sure it's far from perfect, I'm sure we could do things better, but very much built into our work always from the beginning was long-term collaboration, where we worked with local partners, invested in local students, built capacity that builds the long term. And that was probably inspired by my own experience in Brazil in the 1990s, where the Brazilians at that time insisted on strong local partnership. If you were going to work in Brazil, you had to have training workshops for local students. You had to have long-term local collaborations before you would even get permission to do research. And that certainly shaped my work in other places. And I have lots of examples when we worked in Peru. Many of our students were even before undergraduate level, and many of them got trained through the project to masters and PhDs, and some are now professors. As well as working in Peru, we took some of them to then train when we were setting up sites in Africa. We often took our Peruvian students to Africa, and some of them hadn't even been to Lima, and suddenly they were in the Congo collecting data, so that gave them huge experience. So certainly in our own research, but I think more widely, I think it's an important issue. And a few years ago, I was president of the British Ecological Society, and one of my main missions in that was to create this roadmap for global equity in ecology, which looked at these questions of equality, of how science is done. And part of it is what we talked about, this parachute science. There are other challenges as well. The funding for ecological societies and others in tropical countries, So we made changes, like we now insist that more than half of British Ecological Society grants go to the Global South. And there are other ones that, the domination of English as a language of science. You can see why it's useful to have a common language, but actually now in the age of AI, do we need to have everything in English, or can actually people write in whatever language they suit, and actually we can understand and communicate beyond English language the domination. So there are lots of ways in which things can be improved. So we set up this roadmap that I still work with the British Ecological Society to try and create principles of good conduct. So if you are a student thinking about doing fieldwork in Ghana, have to have these guidelines. Or have you thought about this? Have you thought about your partnerships? Have you thought about when you finish your project of going back to the country and telling your partners what you've learned and sharing those ideas? And it may change some models of work. It means that maybe the idea of sending a master's student for 2 months to somewhere just to collect some data is no longer an ethical thing. Unless you're invested in that place and the partnerships, you shouldn't just be sending somebody out for 2 months to just collect some data and come back and do a master's thesis. So it does change some of the ethics of ways of practice there. Just on a more hopeful note, I think that's making progress. We did a recent analysis of co-authorship in tropical ecology and how often partners from the country where the research was done were included as co-authors. So we used ChatGPT to do this because you could extract where the research was done. And what we found is until 2000, the norm was for most papers not to have co-authors from the country that the research was done in. So if somebody was working in Brazil, the norm was not to have a Brazilian co-author on that research. But that changed hugely from about 2000 onwards, starting with Brazil, actually. I think Brazil was the leader. But now the norm, 80 or 90% of papers often involve co-authors from that country. And that's probably roughly what we would expect, because sometimes they're modeling papers or something that don't use data directly. But the countries where this has progressed the most are countries like Brazil, Mexico, India, China, the big countries. But when we look at Africa, we still see this strong inequality of co-local involvement and in this work. So there's a lot more to be done, but there is also things are better now than they were 20 years ago, 30 years ago in this mentality.
So there is a bit of bias towards this side. Should we be more equitable? I do know of a question. So we send a form for students, postdocs, and stuff, if they were too shy to ask you directly. So as far as I remember, I hope that I remember it correctly, but this is a person that is starting their PhD, and they express that they feel that they are very dispersed, no? Like they want to do this and they do that. And when they focus on a specific topic, then they have FOMO, so fear of missing out other topics.
Okay.
So would you recommend them to focus on a specific topic and go deeply into it? Or do you think it's more nourishing to pick up from different disciplines, or maybe, expand this natural dispersion that they have?
This is the conversation I've had with many of my PhD students over time. So I think a little bit like what I said earlier on, I think what a PhD is an opportunity for depth. And then your career actually is one of the few times you have the time to really dive deep into a particular topic. So I certainly think, at least at the chapter level, it's better to have depth rather than breadth in a PhD. Maybe a PhD, the 3 different chapters can look at different topics and bring them together. It's harder once you get later on in your career to ever have that time to really dive deep into a topic and really understand its basis there. So I tend to say, fight the FOMO. Just there are ways in a PhD you can still engage in seminars and discussions and still be involved in the broader intellectual debate. So your PhD shouldn't just be your thesis, it should also be the intellectual climate you're in, coming to seminars, lab talks, journal clubs, all of those things are part of the PhD. But then for your own work, go for depth and really understand the subject and make a contribution to that subject by going deep. And then you have opportunities later to then connect the depth to breadth and broader arguments as well.
I absolutely agree. Any more questions?
We have more questions also that we collected from the forum.
Some of them have appeared, actually.
Yes, that is one still. When you talk about your lab, how many people are working in your lab? Just to have a brief idea.
So my lab now, in my own research lab, the ecology lab, is around 25 people. And then I also direct this Center for Nature Recovery, which is about 40 people, which is multi-departmental, multidisciplinary. So
it's a very large number of people.
I have an administrator and I have a deputy, so which helps.
Yes. And one question related to this is about diversity. Nowadays, you know, it's a topic and something we need to approach. So how do you approach diversity in your lab? Is it something that you take in consideration when you hire someone, or is there any?
I think partially because of the nature of our subject, it's never really been a problem. I mean, the diversity issue we have is, shouldn't we have any British people in our lab? Because they're from everywhere in the world, and very occasionally do we have a European, let alone or a British person in the lab. It's from South America, Africa, Asia, and gender as well. As if anything, it's probably 2/3 women typically in the lab as well. So I don't think we've, just by the nature of the circumstances, we haven't. I think where diversity certainly should be something we flag up is at the senior levels as for promotion. You know, it's more common to get students from all around the world. So when you're hiring for more senior positions, to be sensitive to, are we really thinking? Obviously, ultimately, it has to be about the talent of the person and what they can contribute. But if two people are very similar, how we consider the diversity side of what brings new voices, new perspectives, new cultural perspectives, gender perspectives to the work that we do. So.
It's me again. I have a question about your personal life. Like, not so personal, but but because I think it's like Oxford Academy, it's like this high prestige, like the goal of many people that want to stay in the academia, and I know academia comes with a lot of cost, and I think there's a generational switch in the way people live science now. Like, I tend to think that all the people were only seeking like career stuff, and like they were only focused on their career path, whereas I think younger people tend to try to have some kind of personal work balance. So I'm curious, you are a professor at Oxford. Would you say you have a personal, like a life-work balance that's healthy?
I'd say I have some sort of balance. It changes week to week. Like sometimes I think I'm doing okay, and then next week is just crazy. And partially internal and partially external. Sometimes you have no marking student exams. You have no life for a week when you're marking student exams. But in terms of values, I certainly think it's important to have those down times, rest times, and I sort of always encourage my students to make sure they have that time, and not only because of their mental health, but actually I think the best science occurs when you actually have time to think creatively, to connect ideas together, and outside of in a social space. As I said, the pub is an important part of scientific creativity in my lab, but other places as well, to do that. I have to say I probably think about ecology most of the time, but one way or another. So even when I'm resting, I'm probably like still ticking away. So I don't think I disconnect in that way. But certainly finding whatever works for you. For me, a big part I was describing this is every Saturday I go for a long run. like 15K into the forests and things. And it's not always a non-stop run, it's a nature run. I'll stop and I'll take a photograph of a plant, or I'll listen to the birds. But it's where it's my resting, my recovery, my anchor to recover. And also often ideas occurring then as well. So there are other rituals like that, but I like that because that's a time when I can't be looking at my phone or anything like that. I'm just running and then thinking. So different things. People have different work. I mean, it was a challenge when my family was young. Then you're looking after family, and therefore when the children go to bed, then you have to that's when you have some time to do some creative writing, because the day is busy with administration and things. So there are different phases, but you never solve the problem. There's never a stage when, oh yes, I've worked out the perfect balance, I know how it works. You're always juggling competing demands and trying to work out the optimum. But certainly a culture where you respect downtime, creative time, exercise time, whatever you want to call it, is an important part to me, of a productive and healthy life.
No, they have gone because they knew they had to ask questions.
No, the guys had lectures.
I think they had class.
Yes, they all left. You asked them for questions?
I think they had class.
Sure.
Many studies currently focus on tropical forest carbon sink, but is there any new carbon sink, such as the twin epiphytes or moss? What do you think?
I think in terms of carbon sinks, beyond the tropical forests, I think there's a lot of recognition that the dry lands and the grasses and the soil and the savannas are substantial carbon sinks, as equal to the tropical forests that we didn't think about 10, 15 years ago as a sink. I think epiphytes, probably, I suspect there's too small a component, and I may be wrong, but and mosses, but I think they're relatively minor. It's really long-lived biomass, wood and soil carbon that are the real carbon stores, where you can make a big difference in the long term. But I could be wrong, but I think probably what has happened is we think more about the non-forest biomes, savannas, grasslands, and also below-ground carbon sinks as well as above-ground carbon sinks, where suddenly you see many more processes in many parts of the world. But actually, I have to say, while the carbon sink is important, one thing I've also written about recently is what I call resisting the carbonization of ecology, where so many of our ecological justifications in our grants and papers are around tropical forests are great for carbon, X is great for carbon, and I can see why carbon value can perhaps be an incentive to protect something like we showed in the Amazon, but there's a danger that we reduce all the richness of ecology into carbon stocks, and I think that's dangerous and not helpful.
So we can see the twin epiphytes almost everywhere in tropical forests, but in fact, it can get more carbon sink, only play a little role in carbon sink.
I don't know enough about that to know how much it scales up. Possible, but I think generally the fact that epiphytes are quite short-lived means that they're not, even though you're getting sequestration, you're also losing that. So I wouldn't expect a big sink, but maybe when you scale up, maybe it is.
Okay, thank you, Professor.
Hi, if we've gone back to science, I have a quick question. And I really like the whole, how you were showing us how humans evolved and the metabolism they needed and the one that the ecosystems can provide, and especially the visualization of like the beating heart was really nice. And then at that moment you said that you looked at oceans, but it was a bit messy. And I wanted to know if, when you've looked at it, how does this like balance with human use of nature and then the energy that nature can provide? If you're only accounting for terrestrial part,
yes,
then you're missing like 70% of of the Earth's surface. So yeah, any ideas on?
Yeah, no, I think the oceans, spatially they're complicated because it's not big broad regions, it's narrow zones, so their mapping doesn't work. But the other thing, the oceans are, of course, hugely important, undeniably. One of the challenges is the framing is that on land, our main effect is on primary productivity. And we're taking vegetation, converting natural ecosystems to our agricultural systems. So, of course, we affect higher trophic levels, but our biggest effect is on primary productivity. In the ocean, our biggest effect is on secondary or tertiary productivity. We are harvesting fish, like tuna, predatory fish, even higher trophic levels. And so it's a little bit more challenging to bring into the same framework. One way you can do that is to think, well, what does it take in terms of trophic efficiency to support that higher level? So how many photons does it take to sustain a tuna? And which ultimately feeds through then into the phytoplankton and the zooplankton and the herbivorous fish and all the way up. So there are ways of doing it. And I have somebody who she's hoping to do a PhD with me next year, where we try and take this same framing to the oceans and look at the energetics of marine systems. I think it's solvable, but it's just you actually have to bring in trophic ecology more than you have to on land, because human effects at a higher trophic levels.
Okay, thank you. And then going back a little bit to the connection of science with society, I think I understand where you come from with your definition of being an optimist and this like more pragmatic approach. But I feel, and we were talking a little bit about it, in a time where it feels there is less space to talk about like conservation and like going against climate change, especially that I feel, that's my perspective, at least in the past 5 years, it has been less of a topic as it used to be, that giving more pragmatic ideas or like concepts might hide a little bit of the urgency of the entire thing on like that we need to act on it, and it's easily hidden by stronger voices that have very different messages currently, and not only like in the United States, because like overall in Europe is also occurring. So yeah, finding this balance, I think it's complicated.
Yeah, no, I think that's a very astute observation. I think you have to balance this, this clear pragmatic approach, without it leading to complacency about what we need to do. And where optimism leads to complacency, it's dangerous. And so you have to try and get that sweet spot. So I tend to think, I don't think the optimistic narrative should replace the crisis narrative, but I think we tell both stories. We do tell the story of the urgency of what we need to do, but we also tell stories of actions, ways forward, about creating something positive, not just stopping something negative that we need to do. We need to stop fossil fuels, undoubtedly, but we also need to do something positive as well. And there's a danger that on both sides, I think. Certainly, even if I don't intend to have this nature recovery message to be hijacked. There's a danger that the logging company might say, oh, look, Professor Malhi says you can log tropical forests, it's great. And then therefore, other interests can hijack the science to justify their goals. But being alert to both is the solution. And different people are comfortable in different places. One of my postdocs who works in the Amazon, she's very skeptical about the optimism narrative. She says, we have to talk about the crisis of deforestation and the urgency of it, and anything that's hopeful actually just delays action. I don't agree with that, but I think I can see where she comes from as well, from her experience.
I also have 2 questions. So first one, in the morning, that you were showing that in your plots what you're measuring in the stem, there was the dendrometers and the crown and the root to measure the ecosystem productivity and everything. Maybe I missed, I don't know, but do you do anything, or do you measure anything related to the fallen trees or the decay rates, not just like as a mortality, but in that case? And the second question, how do you protect these plots when there is loss of human influence in these Like you have how many? 100 plots or
Yes,
something?
yes, yeah.
How do you protect your plots?
Yes. So the first one, yeah, we do look at, depends on the questions we're asking. If we're just looking at productivity, we just measure productivity. But if we're trying to look at the whole balance, we have done measurements of long-term decay of wood and come up with these decay coefficients of how long lived wood is, and also after logging experiments, how much dead wood there is and how long it takes to decay to the atmosphere. How we protect plots depends where they are. Sometimes they're protected just by where they are in a strongly protected reserve or in a remote region. But other times they're not. We've lost plots in the Amazon. Some have been deforested illegally, and it's really sad to see, both because you know that plot and its ecology so well, to see it gone. But also obviously the science and that as well. Other times we're seeing global change. So we see fire coming through, or in some of our sites in the Amazon, the forest plots are burnt, even though there hasn't been a fire for hundreds of years. But we let that happen because that's part of the measurement of the processes of global change. And then we try and study, well, how resilient or not is this forest to the fire, to other human impacts.
How old are these plots, more or less?
Depends what you mean. So if we're just doing forest inventories, some of those plots go back to before we started, so from the 1970s, that we inherited and then we carry them on. If with the more detailed gem measurements, the oldest one we set up was in Peru around 2004. But we ran them for about 10, 15 years. Not all the plots are running all the time. Sometimes it's just too difficult to keep something running all the time. But we have the data, so somebody could go back and start again, and we can look at how these forests have changed over time.
And while Paul goes up, is it enough to have 15 years of data? Because I am a dendrochronologist. For me, time has another scale.
Yeah. It's clearly never enough. You can answer different questions at different scales. 10 years, you can see interannual variability and understand those processes. You can also start seeing signals of global change, temperatures rising or a higher CO2. So you can start tracking some of those. And we certainly see those signals there. But actually, one of the decisions we made about 5 years ago is to have less long-term series because they were difficult, and just collect more data from different regions, because we realized perhaps one of the bigger gaps was understanding the spatial variation. The tropics are huge, tropical forest biome, and there are so few plots for this. So we try to develop more.
And this goes like in the space for time approach, or something like this?
Sometimes it's just space for space, just to get more understand the biogeography. But sometimes, when we're looking at some of the logging experiments, trying to get chronosequences, and trying to use that, or space for environment, so the elevation gradient as a way of understanding temperature controls.
Thank you.
Thank you. I'm not early career anymore, but I couldn't take. I want to take advantage of your presence here. So a couple of questions. The first one is that, I'm doing science. I'm studying greenhouse gas emissions from forest. And on the one hand, I do it because I just like it. And I'm wondering what's happening there, what's driving those fluxes. But ultimately, I'm doing that because I want to make a change and make an impact to politicians, stakeholders, managers. But many times they think that when I apply for funding, say, it's not really worth it because, please, I hope that no one that's funding is hearing me, but we already know enough to make a change. And if we are not making change, so it's providing more evidences gonna change anything. Many times I had the feeling that we already know enough for acting, and we are not as a society. So is it really worth? For me, it's worth because I keep doing what I like to do, but I have the feeling that I'm not making any change because So climate change, global warming, elevated CO2, we already have evidences from the late 19th century saying that's what's going to happen, and we are not acting or not as fast as the disturbance that we are producing. So can you cheer me up and tell me why it's still important?
Sounds like we're having a counseling session now. I mean, firstly, I think curiosity is an important value in science. It's okay to, certainly I think where possible our science should always have application to these challenges, but it's okay sometimes just to be curious as well and just to find out how the world works, and certainly for me that's a big part of what motivates me as well. I think your research, you're right in the sense that we know enough. I don't think what's delaying action on fossil fuels or other things is lack of knowledge. I'd say the two biggest factors, say, on the climate change problem are inertia, societal inertia and just shifting, and secondly, vested interests, companies and others that benefit from the existing system and don't want to change it. I don't think we need more science to solve that aspect of climate change. Maybe particular things that we might want to think about think of biological science here, like the ecology of carbon capture or biofuels and these things, for sure. But in terms of do we know whether we should act or not? We know we should act, undoubtedly. But I think the science still feeds into the arguments beyond that. One example I gave was the Amazon and the carbon sink and how that influenced the value of our forests and hopefully slow down deforestation. And sometimes those acts are not directly linear. It's not that your science led to this result, but your science fed into this body of work and evidence that eventually helped shape the narrative, helped shape the outcomes of a solution. And I would say on that side, yes, certainly we've done some steps back, but I think that we're sometimes dominated by the story of what's problems of the last year or so, rather than actually the broader progress still happening. It doesn't get all the attention and the headlines the same way as the negative stories do. I think science is more important than ever, and I think it's perhaps how you frame those questions in the grant. If you say, we need more evidence before we can do something, I think that's wrong. But I think we need to understand this better, because this can help us refine what we're going to do, or how these systems may, depending on the question, how they may be resilient, or how they could be enhanced to be more resilient to climate change. I think those are all valid reasons to justify more research.
Yeah, and the second question, it's more practical for people working in academia and pursuing this career, is that I've been told plenty times, don't go to the field anymore. It's way more expensive, it takes a lot of time to get the data, so why don't sit with your computer, compiling data, upscaling, doing something that's going to be more global, it's going to be more easy to publish in high-impact journals or something like that, so don't waste your time going to the field. But I'm a field person, so yeah.
Well, I can tell you I utterly disagree with that advice. It's in fact the opposite. I insist that if I have students who are doing modeling or remote sensing PhDs, that they go to the field, help somebody else in a project, so they understand the system, that they understand data. And I think, okay, maybe I disagree, because maybe you could argue you don't get the higher impact nature papers because field work doesn't do that. I disagree. We've got papers like the ones I showed that are field work and have high impact science. And the one on methane that you were involved with is a perfect example of field work that led to a nature paper. And I think it's one of the most important values in ecology is empirical data collection. And so I would strongly disagree with whoever advises you to not go to the field anymore.
It's true, but we have to be fair as well, saying, or realistic, I don't know if realistic is the word, but if you're doing mostly field work, it takes longer, so you publish less, and at the end we are competing for grants, for fellowships, for projects, and if you have published more or more impact, you're going to be more success and more likely to keep working in academia. So it's, I agree with you 100%, and that's my choice, but it's a choice that it has taxes. So you pay your
It takes
your
longer. Maybe I'm biased in my experience. I'm sure I am biased. I haven't found a career that's dominated by fieldwork has caused damage. I think actually, in a field that's quite crowded, being a scientist who made their career on empirical research in difficult places probably gave me an advantage, a niche in my career development. In when all of these global models of Amazon dieback and biosphere were there, and I was one of the scientists on the room that could actually talk about real experience, about real rainforests and how they work and the complexity of those forests. So, and I still think that's true. I think, I'm trying to think of when I see job applications, do I go for the person who's amazing at big data and doing things, or do I go for someone who's produced some really interesting science that has taken longer in really interesting places? I'd have to look at the cases, but I would certainly not be biased against somebody who's taken longer to produce really good science.
I wanted to add to that, actually. It's really nice to hear from someone as prominent as you are in your field talking about that, because I think that sometimes we don't realize that we sometimes are part of the problem. When we look at the CVs of people, you can look at it very nuanced, and maybe we should break the wheel as well. So we should be part of the change as well. Sorry, I just wanted to add this. I wanted to ask you, it's a question that I almost always ask to the Margalef Prize awardees, so sorry for not being so original, but we have been talking about these pessimistic messages that we get, and I really like that you brought a bit of optimism, but I have the feeling that it's very complex to explain the nuanced reality of things as they go, and when our knowledge gets filtered through the media or any other channels, it gets polarized. It's either good or bad. I would like your take on that, on how can we do to express how complex is nature, the patterns that we see, and the impacts that we do. How do you have a solution for that? Maybe you don't, and that's absolutely fine. But I would really appreciate your take on that.
Yeah, I think you can tell stories that respect complexity, but then still tell compelling stories. The danger is, perhaps sometimes in our scientific training, we really weight the complexity and miss the core story, the narrative that's behind that as well. And because we're trained to be worried about the uncertainties and the complexity and the evidence fully, and forget to tell the clearer story, that partially because we almost take it for granted. Oh, everybody knows the forests and climate change or something like this. So I think partially, perhaps even learning the skills of telling good stories ourselves as researchers, or if you don't feel you have those skills, working with storytellers who, whether in media or in other ways, that are able to take your science and tell compelling stories with that. That I think respect the complexity, but still tell the wonder and the significance of the story that you're telling. And I tend to think that that's quite possible. And when you hear a really good science communicator telling really inspiring stories, which you still respect because they're not oversimplifying, or they are simplifying because they have to tell a good story, but they're not excessively simplifying or fabricating. It's really can be quite inspiring for you as a scientist, but certainly for the wider public as a way of appreciating the wonder of science and the wonder of ecology.
We have.
Well, it's just we are here because of Margalef. I just want to remember, maybe the young people don't know, but Margalef was measuring a lot of things, going to the field, was a great naturalist, so knowing nature, observing nature, and from that is when he ended up with all this complexity analysis to how the system works, but was very, very important. He's looking at nature and learning from that. So it's measuring, quantifying, analyzing, thinking on how to. You were mentioning during lunchtime the importance of the protocols when you go measuring to be comparable to other measurements, all of those things. No? But he also was inventing devices at that time to measure things. So it's, I think this field work is inside the ecology and is very needed. Despite, yeah, it's good to have the two ways, the getting inside the measurements, but then understanding and trying to integrate and to think how when we plug everything together, that work.
Yes, yeah.
So it's,
I remembered a good story of how field experience can change the way you think. And we'd set up this GEM project, which is very much vegetation focused. And we set up some plots in Gabon, in the Congo Basin. And then one day we were setting up, and there was an elephant in the forest, in the plot. And it chased us. I had to run for 3 minutes with this elephant chasing me through the forest, which never happens in the Amazon because there's no elephants. And then after I got my breath back and thought about it and thought, wow, animals like this really shape this ecosystem. How is this forest different? And all my Amazon thinking in terms of an animal, poor forest, was changed by suddenly being in forests that were rich in animals. And that started me thinking, well, how was the world when it was rich in animals, and what are the legacies? And all of the turn, you could argue that all of the turn towards energetic thinking and multi-trophic thinking started off being chased by an elephant in the field when I was trying to measure plants. So sometimes field work can give you experiences that take you in different directions, make you think, if I'd just been in the desk modeling plants, I would never have met the elephant, and I would never have changed my thinking probably.
There was a very simple and pragmatic question that someone wrote in our form, but I think it can be very inspiring, is when you need to write a paper, how do you do it? How do you approach a paper? How do you start your writing, the writing process?
Yes,
I think it's maybe useful for people here.
Well, the advice I give my students is start with the results and the figures. So to work out, obviously have conversations and work out what the story is, work out what your key 3 or 4 figures are, and write the results around that. And then write your introduction and your methods, and then your conclusions. The temptation when you start, obviously, is often to start with the introduction, and you can always tell a paper written by somebody as their first paper, because the introduction tells you everything they know about a subject before they get to the question. And so I think starting with what's the core message you're trying to show, and then working back to justify that, and is often a good tip. And then in terms of the blank page problem of how do you even start, I think if you're struggling to think of what to write, just getting down the bullet points. These are the 4 or 5 key points I want to make about what I've learned in this study. And then you can build up the writing around that as well. But just getting clear on your message and the few points you want to make, not too many. If you're making 7 messages, it's probably 2 papers or 3 papers that you need to write rather than 1. If it's 3 or 4 clear messages, that's good.
Yeah, totally agree that at the beginning it's very easy to spread around the topic.
Yes.
Okay, thanks. Yanis?
Continue a little bit on one of the things that Paul was saying now, and you mentioned as well in the talk how difficult it is to get funding for continuous monitoring that are not as flashy and nice, and also sometimes when we talk about academia and the entire publication-based system and ranking people, as scientists we talk about it as something that is imposed on us, but we kind of perpetuate it, no? Because we feel like we form part in most of the steps, even getting grants. Sometimes there's a scientific committee behind it that is other scientists. So in this sense, is it? Have you seen any trend of this getting a little bit better, or why do we keep ourselves like perpetuating this system where I think in general there's a sentiment that's not the most fair or the most, I don't know if fair is the word, but like the most easy system to have, let's say, I don't know.
Yeah, well, I think in terms of long term, there's a genuine trade-off. Given a finite budget for research, how much do you put into long-term monitoring of a few sites, or versus the innovation that comes from more grants for short-term, 3-year projects, exciting new ideas are being developed there as well. So a long-term commitment to a long-term funding under conventional research council funding comes as a trade-off. If you're locking in 10 years of money into that research site, that's less money for new grants for new things. So unless the whole funding pool increases or there's extra funding. So I think the challenge is to make sure arguments are made, different sources of funding that support this as sort of baseline ecological monitoring rather than as research grants. So the research grant fund is still there. In terms of propagation of the system, certainly there's elements of that I think we as academics can challenge overall. I mean, I sort of mentioned we have a Nature paper coming out today. Like there is this hierarchy with Nature at the top of the ladder, and it's hard to you can say, oh, don't worry about that, just publish a paper in a good journal. But as you say, in this market of jobs and things, well, people do look at papers at the highest impact for competitive jobs. So it's hard not to do that. But I think we can still push against that to some extent. Taking the example of Nature, for example, yeah, maybe the highest impact papers, you should still think of Nature. But this proliferation of thousands of journals with the Nature title is just destructive. Actually, you don't have to be in some journal that has Nature somewhere in its title just because it has Nature in its title. There's actually really good society journals, like this Journal of Ecology, that has a really good home for that paper, has just influence. So let's not buy into this mentality. It has to have the word Nature in the journal because that doesn't actually help as well. Those journals aren't particularly high impact or something. It's just perpetuating this mentality there as well. And there are many other examples. I mean, the whole system is challenged. The whole publishing system is challenged at the moment for many, many reasons of how can we make it sustainable when it requires the free time of reviewers for the profit of publishers. The whole model is struggling. So maybe there's very radical different solutions that are being experimented with online publication, with the light peer review or community peer review. None of them has really taken off, but I think the model that exists was really invented in the 1960s, and I think it's dated as a model for disseminating scientific knowledge now. I think we should focus on publishing quality papers. I certainly feel in the UK that has happened, and previously the number of papers you published mattered, but now when we do these assessments, it's really every 5 years they say, what are your top 4 best papers? So it doesn't matter if you've published 20 papers or 5 papers, what's your 4 biggest contributions? So I don't think as individuals necessarily we publish. Now what has happened, which is a good thing, is that there's a much wider community of academics publishing. Now suddenly China's really prolific, Asian countries, Latin American countries. So the volume of publications has increased for that reason as well. And that's a good thing overall. It does mean it's opened up things like these predatory journals and things that really don't do peer review and just publish anything. It has become, so we publish a lot. I think on the good side, that's in ecology, that's removing the bias that has been very much North American centric in the literature that we read. The challenge is how do you even keep up with it? And I think this is again another area where AI and tools are actually other tools that are providing really powerful ways of understanding, synthesizing information quickly and finding out where the latest developments are. It doesn't substitute reading papers, but in identifying key papers and key trends in the field, I think there's a lots of potential there of sifting out the really quality information from the sea of information that we're drowning in now.
When you were describing how the way to write the paper, but I was imagining also the way we are reading the papers. So maybe you are attracted by the title, but then you go to the figures, the tables, okay, and then maybe you go to the methods, how this is being measured, and then you go to, okay, what is the context of that? Or, yeah, but I think we tend, because now with this new way of having so many papers, you know, in the past you have to go to the, you know, the
physical journals.
Yeah, to the libraries, and then you have the, you know, the physical papers. But now you have this flood of information when you just look for a subject, no? And then, yeah, okay, you can look at the summary, but basically what is the most interesting is to look at the figures, the tables. What is this providing? And then from that you move around. I don't know if you.
Yeah, very, very much so. If you, perhaps with a paper, you start with the abstract, you get a sense of what it's trying to do, then go to the figures to see, is there something really interesting there that's grabbing your interest? And then if it does grab your interest, then you go in and look more critically at the argument and the methods. And
hombre.
Okay, so I had two very different questions. The first one was, like, if you have done a community, I don't know how to say it in a proper way, do the same as you did with mammals and birds with a plant community, so like assessing how much energy is going through a certain species in a tropical forest or something like this, or you just measure the soil carbon balances and the canopy carbon balances? And then the second one was, I think you almost answered it about the AI tools. How do you see this technology? How are you approaching it in your lab, like openly discussing about it and finding ways to, what's your insight on that technology and the new skills or tools that it can provide? And really amazing talk in the morning, so thank you.
Yeah. Thank you. On the plants question, we haven't done that, and I have thought that we could in principle. So if we know in our forest, we know the basal area of each tree, so we can estimate the canopy, the leaf area, so you could then partition the productivity by leaf area of each tree and look at how many species it's going through. So in principle, it can be done. We haven't done it, but I think it would be quite a nice student project to try and do that for our site, so maybe we'll try. On AI, generally I think I have a fairly positive attitude towards it. As does our university, it's formed this relationship with OpenAI, where we have our own version of ChatGPT internal to Oxford that's protected from being sucked up so you can put confidential information and it won't go into the global model. So the universities have been quite positive about using it as well. I think, like any technology, there are ways that are good and bad, so you have to just work out the ways that are positive. But I found in my own work, I only really started using it this year, I find it a really useful research tool, research complement productivity tool that I can quickly, if I want to assimilate a body of information, searching in an AI tool to understand the key arguments, the counter arguments in a field that I don't know very well. It's amazing as an introduction to asking questions and finding out things that then you can follow up by reading papers and doing other things. As I said, one other positive thing is about language, that I think it really frees you from being constrained to English as the language of science. So if I want to read a Russian paper, I can just upload it into AI and it can give me a translation of that Russian paper, and things, amazing things like that. That's weren't possible before. There's this concern that AI will make us somehow more stupid, less creative. That somehow we will stop being creative because AI is doing. I don't tend to agree with that. I think most tools make you more creative. I remember in the 1970s when I first got a calculator, my father would say, "Oh, this calculator is going to make you more stupid because you're not going to do the calculations. You're just going to do it there." But now we've even gone beyond calculators. It actually enhanced your ability to do things if you use it the right way. If you use it as a substitute for your creativity, then it's a problem. But if you use it as a complement to your creativity, I think it makes new things possible, new ways of connecting different subjects. It helps solve this problem of too much information. It helps you distill this complex world of information. It has its biases, so you have to be aware of those. But also, I think it also counteracts your own biases. So rather than just reading English language literature in the Web of Science, suddenly I'm reading wider literature that I wasn't aware of, because the AI can find things that I wouldn't easily find in a quick search on Google or something like that. So obviously, I think there's the concerns around footprints of AI and things. I think we have to think about that. I think, at least in the European context, it seems like a lot of the energy system is moving to renewable powered data centers in relatively water-rich regions like Scandinavia. So the same concerns that you'd have in an arid region are maybe not so apparent there. But we have to be aware of that for sure. But I think as a technology, it opens up lots of possibilities, and I think the field can benefit from that. Ecology can benefit from that.
So, is there any other burning question before finishing the session? No?
I'm going to make one final comment, which I just want to say that I think for all the challenges in academia and jobs and things, all genuine problems, I think it's a huge privilege to be able to do what we do, to study the natural world, to have the freedom of time to think deeply about that as well. And it comes with the challenges, and we must be realistic about those as well. But we should also respect that privilege, take advantage of that, and use that both for our curiosity, but for the betterment of society as well. So I think to be an ecologist is amongst the best things in the world to be.
Totally agree with you. And well, first of all, I also want to thank you, because today you made such an effort to connect your talk to Margalef's work, and I think it was very nice and I really like it. And well, I think we can say that thank you for your time. It was a lovely afternoon, and it was very nice to have this opportunity to exchange with you, not only about science, but beyond. And and thank you all for coming and for making questions. It was very nice. So thanks a lot to all of you.
Thank you. Thank you. Lots of good questions as well. So thank you. And hopefully I left you more optimistic, not less.
It was very nice.
Okay.
Sí, els anotem. Aquests...
Sí, jo recullo un parell de coses d'aquí darrere. Sí, he quedat aquí aquestes tasses abans.
But of course,
more
it's,
or less chance.
well, I hope you enjoy Barcelona and it's a good time.
Thank you.
That's lovely to hear your answer as well. I imagine you might be a bit exhausted after the whole day. So thank you very much. Thank you very much.
It's very good, but very nice.
I'd love to have a quick look at the library if you have 10 minutes.
Yeah, we can. Otherwise, I think tomorrow morning, if you arrive a bit earlier,
Okay.
maybe I just also working with, if you come around 9, maybe.
Okay, what time can run with the time?
Tomorrow is 10, 10 to 12.
Okay, yes.
So if you arrive a bit early, like 9, we'll have
Yes.
plenty of time, maybe even. Okay, we can go.
Yeah, that's good.